Now, the second example are the pattern detection algorithms that are used in so-called causal states in computational mechanics. This is the work of Crutchfield and Naturalism, where a causal state is an equivalence class in which all of the causal histories of a state have the same conditional probability distribution for future observables. Now, those states almost certainly have no compact representation in human languages. And indeed, since the machines operate on purely extensional representations, directly raise the problem that intentional characterizations of properties are likely to be too sparse to capture these kinds of extensionally characterized properties that are used in that part of computational science. Now, this strongly suggests that philosophers of science will need to do one of three things. They'll either have to expand their repertoire of representations to include those used by computational philosophers, or they'll have to concede that certain current and future scientific activities lie beyond human understanding, assuming that understanding requires possessing the relevant representations. Or, thirdly, push their explorations of things like subconceptual, non-representational, and non-conceptual content beyond the realms that are currently being explored in artificial intelligence, such as the use of dynamical systems theory or neural net representations. Now, the second theme of extending ourselves is the need to move beyond the anthropocentric orientation that has dominated, albeit separately, philosophical accounts of, on one hand, empiricism, and on the other, the a priori. With rare exceptions, definitions of a priori knowledge, a priori justification, a priori propositions, and so on, have, for perfectly understandable reasons, been grounded in human psychological capacities. A clear exception to this orientation is Friedman's account of the a priori, in particular the constitutive a priori. Moreover, the constitutive function of the constitutive a priori principles carries a heavy representational content. And finally, Friedman's account of the rationality of transitions from one basis to another carries morals for the kinds of transitions from anthropocentric to non-anthropocentric conceptual framework in which I'm interested. Okay, so that's the background. Now, let me now move on to talk about the a priori and the role of idealizations in philosophical methods. It's been recognized by most people since the failure of Descartes and Leibniz a priori systems of mechanics that a knowledge of scientific laws is unlikely to be arrived at through a priori reasoning. It's not impossible that such a success would have to be an epistemic accident. The related moral about ontology seems to have escaped many metaphysicians. For example, take the limit of zero resistance in a suitable conducting material, it's usually achieved by lowering the temperature, and you've moved into a distinctively different physical realm, one in which not just Ohm's law is false, but the ontology changes as the conductive carriers, which are originally electrons, are replaced by a Cooper-Pairs superfluid. The fundamental problem here results from what one might call the anthropocentric predicament, which affects both the a priori and the empiricist attitude towards the a posteriori. Both are focused on the centrality of humans, which are inescapably middle-sized objects with limited cognitive capacities. One of the great scientific shifts in perspective was the 20th century realization that physical phenomena were not universally scale invariant. That classical mechanics did not extend unchanged to the realms of the very small or the very large, nor, as a result, was it exactly correct in the realm of the middle-sized. Once we had that realization, the status of the human a priori and of human experiences as sources of knowledge should have changed dramatically. The traditional a priori should have had its scope severely constrained because our native conceptual apparatus is shaped by middle-sized experiences. Traditional empiricism should have been modified because our perceptual apparatus is constrained in parallel ways, at least for evolutionary reasons. Yet our modification has not been taken seriously in many areas of contemporary metaphysics. It's this issue of scale that lies behind many of the deficiencies of analytic metaphysics. Much of metaphysical argumentation has deep similarities with the arguments that accompany thought experiments. And when constructing a hypothetical scenario, we need to know the laws and specific facts that apply at the scale at which the scenario is described. The only source of that knowledge is science. Our intuitions and a priori imagination and reasoning are not equipped to provide it. At least some of the problematical examples of naive metaphysical reasoning arise from simply assuming scale invariance when the subject does not in any way exhibit such an invariance. For example, many of the original discussions of Maxwell's demon did not account for the fact that at the molecular level, thermal noise from the uncertainty principle undermine the ability to manipulate the trapdoor so that it emits molecules with a preferred directional velocity, and that turned out to be crucial in the analysis of that particular scenario. Now, with regard to idealizations, as in science, philosophy resorts to certain kinds of idealizations in order to achieve its goals. And in order to arrive at a perceptible scientific metaphysics, the use of idealizations in the two fields should cohere with one another. Indeed, it's the inappropriate use of idealizations in some kinds of metaphysics that is a reason to not use them. I'll take as my target the use of a priori reasoning and intuitions in non-scientific metaphysics. And I'll begin with non-perceptual intuitions. The justification for a priori statements is often claimed to be, and unavoidably so, rational arguments that are grounded in premises that can be justified only by intuitions. Now, intuitions, of course, have an unsavory taint for many of us, but I just want to remind you that they're not intrinsically unacceptable. Here are two statements. The view is by no means restricted to metaphysics. A similar position was voiced by the logician J. Berkeley Rosser when he wrote, "The average mathematician should not forget that intuition is a final authority." When I put up that quote, I started wondering what he meant by average. Yes, indeed. A view, Ross's view, that's clearly opposed to that held by Frege, the quote here, Frege's begriff shift is to prevent anything intuitive from penetrating the realm of arithmetical reasoning unnoticed. I had to bend every effort in order to keep the chain of inferences free from gaps. So I put that up there just to show that intuitions are not clearly unacceptable in all areas, and that there are serious issues involved in the appropriate use of them. Now, two of the most obvious problems with intuitions are that first, they tend to differ, often considerably, between philosophers. And secondly, they're often wrong when they're not about everyday experiences, because we have no prior knowledge base on which to draw. Skip ahead. Intuitions, like other epistemic methods, are not uniformly reliable, and any metaphysics that results in their being reliable across all cases of a priori knowledge is inherently suspect. For example, intuitions about probability are notoriously shaky for most people. One famous example being the Monty Hall problem. If you don't know this, not to worry. There's a correct answer to the problem, and most people arrive at a wrong answer when they approach the problem intuitively, even reasonably sophisticated people, so that their intuitions have to be corrected either by arguments or by real or simulated frequency data. So one thing that needs to be done, just as we must in the case of instruments, is to specify a domain of reliability for intuitions of a particular type, such as geometrical intuitions, number theoretic intuitions, probabilistic intuitions, moral intuitions, and so on.